Welcome back to Talk Tensors, listeners. Ready to brew up some insights from the latest machine learning research?
Always ready for a good brew.
Today, we're diving deep into, well, get ready for it, ReFocus. Visual editing as a chain of thought for structured image understanding.
Quite a title, isn't it?
It is, but don't let that scare you off. This paper, it's tackling something really interesting in the AI world.
Absolutely. It's all about those multimodal LLMs, the ones that can work with, both text and images, and how we can get them to really understand what they're seeing, especially when it comes to charts and tables.
It's like we humans, we can glance at a graph and boom, get the trend. But for AI, that kind of visual reasoning, well, it's been a real struggle.
Yeah, it has. And that's precisely where ReFocus steps in. This paper, it's introducing this, a pretty clever new approach, giving these LLMs the ability to kind of edit images, but using Python code.
Python code. Sounds a bit technical.
It is. But stay with me. We're not talking about, Photoshop here. Think more like highlighting important rows in a spreadsheet, maybe masking out some distracting columns, or even drawing boxes around, say, key parts of a chart.
So it's like giving the AI a set of tools, almost like virtual tools, to help it zero in on what's important.
Exactly, like how we might circle a key number on a report, or use our finger to, follow a line on a graph.
Right, right. It's giving the AI a way to kind of think like we do.
Precisely. And the really exciting part, the results they're seeing with this approach are, quite impressive.
Okay, I got to ask, what kind of improvements are we talking about here?
So they tested ReFocus with GPT-4 on all sorts of structured image understanding tasks. And on tasks using tables, they saw, on average, an 11% gain. And for charts, a boost of 6.8%.
11%? That's massive.
It is. In AI research, those numbers are, they're not just good, they're kind of a big deal.
I bet some folks might be thinking, hold on, isn't this just giving the AI the answers?
That's a fair question, but here's the thing. ReFocus isn't giving the model any new information, really. It's more about helping the model use the information that's already there, but in a smarter, more efficient way.
So it's less about spoon feeding and more about teaching it to think strategically.
Exactly. Like instead of just highlighting the key points for a student, you're teaching them how to analyze the document themselves.
The paper mentions something about visual grounding and OCR and how those improve with ReFocus. Mind breaking those down for our listeners who might not be familiar with the terms?
Sure. Visual grounding at its core is about making sure the AI is, looking at the right part of the image when it's trying to, answer a question. And OCR, that stands for optical character recognition. Basically, it's the AI's ability to, read the text in an image.
So if the AI can't figure out where to look or what it's even reading, it's going to have a hard time understanding anything.
Exactly. And ReFocus tackles those issues head on. By, guiding the AI's attention, it makes grounding more accurate. And that, in turn, boosts the OCR accuracy as well.
It's all connected.
It is. And it's exciting to see how this system isn't just improving what our current LLMs can do, but it's hinting at what might be possible for future AI that can really see and read the world around it.
That is exciting. But to really appreciate what ReFocus is doing, I think it helps to understand how we got here, the history of it all.
I agree. This paper didn't just appear out of nowhere. It's building on decades of research in, AI, computer vision, natural language processing. It's a whole tapestry of ideas.
So let's rewind the clock a bit, way back to the early days of AI. Where would you say the story of visual reasoning in AI begins?
Well, in the very early days, the main approach was something called symbolic AI. Researchers were basically trying to, hand code knowledge into machines.
Symbolic AI. The days of painstakingly crafting those rules and representations for, every single scenario.
Exactly. And while it worked okay for very specific problems, it was just too rigid to handle the complexities of the real world, really.
It couldn't adapt.
Right. And then came this huge shift with first statistical machine learning, and then deep learning just blew everything wide open.
A true paradigm shift. AI could suddenly learn from data, find those hidden patterns, make predictions. We saw AI systems recognizing faces, translating languages, even playing Go at a level that, blew human players out of the water.
And this data-driven revolution, it completely changed computer vision, too. We saw convolutional neural networks, or CNNs, take center stage. They were
Yeah.
specifically designed to, well, to process images.
CNNs are game changers. They let AI systems identify objects, classify images, even create those super realistic looking images you see online.
And all of that laid the groundwork for the multimodal AI systems we have today. The LLMs we're talking about, the ones that can process text and images.
Which brings us right back to ReFocus. It's like it's taking the best of both worlds, right? The power of deep learning, but with this added, more structured, more attention-driven approach to visual reasoning.
You nailed it. It's acknowledging that sometimes just throwing more data at the problem isn't enough. Sometimes you need to guide the AI, give it those tools to process the data in a way that's more intelligent, more like how we do it,
Right, like how our brains work.
Exactly. And that's why this paper is creating such a buzz. It's not just about making our current AI systems a little bit better. It's about pointing towards a future where AI not only sees the world, but it truly understands it.
And that opens up a whole universe of possibilities. Speaking of possibilities.
Sounds like it's time for novel notions. The part of the show where we step outside the paper itself and explore some of those more speculative research avenues, those what ifs inspired by what we've learned.
Let's do it.
Welcome back to Talk Tensors. Let's dig a bit deeper into ReFocus. How it actually works. You mentioned they tested it on both tables and charts.
Right. They focused on those specifically because, they're everywhere, right? Tables and charts. But even though they're so common, they've been surprisingly tough for AI to really get.
Yeah, and for good reason, really. It's not just about recognizing those visual elements, the lines and the bars and such. It's about understanding how they all relate to each other, extracting the meaningful insights from them. Like, think about a financial spreadsheet. We can glance at it, pick out the key numbers, maybe spot some potential risks or trends. Getting an AI to do that, it's been a real challenge.
So how does ReFocus actually tackle that? Walk us through the technical approach.
Sure. So the key here, the real innovation, is giving the LLM, and in this case it was GPT-4o, giving it a set of tools. And these tools are basically Python functions.
Python function.
Yeah, and these functions allow the model to do what they call visual editing. But it's not like, Photoshop editing. It's more about programmatically highlighting or masking specific areas of the image. It's all about guiding the model's attention to where it needs to be.
Okay, starting to get it. So for tabular data, like our spreadsheet example, these tools might include functions to, say, highlight a certain column or a row, maybe mask out a section that's not relevant, or even draw a box around some key cells.
Exactly. It's like the AI is using, it's like a virtual highlighter, zeroing in on those important data points.
Right. And what about for charts?
Well, for charts, the tools are going to be tailored to the type of chart, of course. So for a bar chart, the model might have functions to, say, highlight all the bars that are above a certain value, or maybe all the bars that belong to a certain category.
It's like the AI is focusing in on what actually matters, cutting through the noise.
That's the idea.
But how does the AI know when to use these tools and how to use them? That's where the chain of thought part comes in.
Yeah, you got it. So the researchers, they prompted GPT-4o to not only answer the question, but also to kind of explain its reasoning process as it went along, step by step. And that includes saying which visual editing tools it decided to use and why.
So it's like the AI is, writing out its thought process?
Yeah.
Justifying every decision it makes?
Yep, exactly. It's not just about getting the right answer. It's about making sure we understand why it arrived at that answer.
That transparency is huge when it comes to, building trust in these AI systems. So did it work? Give us the bottom line. What were the results like?
Well, the results were, pretty compelling. Across a bunch of different benchmark data sets, ReFocus consistently did better than just using GPT-4o without the visual editing. And we're talking significant improvements on, things like table question answering, chart comprehension, even logical reasoning based on visual data.
Those are some bold claims. But I talked about it earlier. Some folks might be skeptical, thinking that, maybe the visual editing is kind of like giving the AI an unfair advantage, like leaking the answer somehow.
Yeah, it's a valid concern. And the paper, it addresses that head on. They did a very thorough analysis to show that the improvements were really because of better visual reasoning, not because of some trickery. They showed that ReFocus wasn't actually adding any new information. It was all about helping the AI use what was already there, just more effectively.
So it's more like instead of giving someone turn-by-turn directions, you give them a map.
Yeah.
They still got to figure out the route, but the map helps guide them.
That's a perfect analogy. So they essentially proved that ReFocus isn't some hack. It's a genuine improvement to how the AI thinks about the visual information.
That's impressive. So how exactly did refocus improve things?
So they looked closely at the AI's outputs, both with and without refocus, and they found that the improvements really came down to two key things. First, refocus significantly improved what we call visual grounding, basically making sure the AI was, well, looking at the right parts of the image when it answered a question. It was less likely to misinterpret the question or get distracted by, irrelevant stuff.
Like giving the AI a pair of glasses to see the data more clearly.
Right. And the second thing, they saw a big boost in OCR accuracy. By highlighting or masking certain areas, the AI it could read the text in tables and charts much more accurately. So it had a better understanding of what the data actually said.
Okay, so it's improving both how the AI sees and how it reads the data.
Exactly. And they took this even further. They did another experiment, this one involving fine-tuning.
Oh yeah, the fine tuning. This is where it gets really interesting.
It is. So they wanted to see, could they somehow distill the essence of refocus, this whole active attention mechanism? Could they bake that right into the AI's learning process? Could they teach the AI to, think like refocus, even when it didn't have those explicit visual editing tools available?
So basically they were trying to make those visual reasoning strategies a core part of the AI itself.
Exactly. They wanted to internalize those strategies, make them an inherent part of the AI's, its cognitive toolkit.
Like if you're teaching someone how to solve a math problem, you don't just give them the answer, you show them the steps, right?
Perfect analogy. So they collected this data set of, image question answer pairs, but each example, it also included the chain of thought from refocus, including those decisions about which visual editing tool to use and why.
So they were giving the AI those worked out examples, showing it both the answer and the thought process behind it.
Right, and they used this data to fine-tune a smaller language model, one called Phi 3.5 Vision, and the results, they were pretty remarkable. This fine-tuned model, it significantly outperformed the same model trained on, the standard image question answer pairs. It had basically learned to mimic those visual reasoning strategies from refocus, becoming a much more visually aware learner.
That's incredible. It's almost like they gave it a new way to think about images.
In a way, yeah. And what it suggests is, it suggests that this whole approach behind refocus, it could be a key to developing this whole new generation of AI models that can truly see and understand the world around them, not just passively process pixels.
And that opens up all sorts of possibilities for
Yeah.
how we use AI in the real world, right?
Yeah.
For analyzing data, for solving problems, for just about anything.
Exactly. And speaking of real world applications, I think it's time to shift gears a bit. We've explored the technical details, we've seen the promising results. Now let's think about how this could actually impact how we interact with technology. This isn't just theoretical, This has the potential to really change things.
Let's hear it. What kind of applications are we talking about? Welcome back to Talk Tensors. It's time for everyone's favorite segment,
Novel notions.
Novel Notions, where we take those insights from the paper and see where they lead us, explore those more speculative research avenues, maybe those what ifs that might sound a little out there.
Time to push the boundaries, right? See what might be possible, even if it's a bit far out.
Exactly. So we've talked about how refocus gives AI this ability to
Yeah.
edit images using code. But what if we took that visual editing idea a step further? What if we added the concept of, visual feedback?
Visual feedback, huh? Interesting. What you thinking?
I'm thinking, imagine an AI system that could not only analyze an image, but it could actually generate its own simple visual outputs as part of its reasoning process. Not like full-blown pictures, but, more like sketches, diagrams, annotations, things that represent how it's understanding the image.
Ah, I see. So it's like giving the AI a virtual whiteboard, right? To kind of sketch out its thoughts, make its reasoning process more visible to us humans.
That's it. So, for example, imagine an AI that's trying to, solve a geometry problem. Instead of just crunching numbers, it could draw a diagram, highlight the important angles, the lines, that sort of thing. Or maybe an AI that's trying to summarize a really complex scientific paper. It could create a simplified flowchart of the key processes.
That's really interesting. It's almost like giving the AI a new language, a visual language to communicate with us. And that could be incredibly valuable for a number of reasons, actually.
Definitely. For one, it would make the AI's reasoning, much more transparent. Instead of just getting an answer, we'd be able to see how it got there, how it broke down the problem, the logic it used, all of that.
Transparency it's crucial, especially when we're talking about AI. And this visual feedback loop, it could also be a great tool for, well, for debugging and improving AI. By looking at those sketches, we could see where the AI might be misinterpreting something, making a wrong assumption and be like peeking into its thought process.
Right. Seeing where it's getting stuck or where it's having those aha moments.
Exactly. And it could even lead to new ways for us to collaborate with AI. We could interact with those sketches, give feedback, offer guidance, have a back and forth, like a visual dialogue to solve problems together.
Now, that's a cool idea. Humans and AI working together, not as competitors, but as partners, each bringing their own strengths to the table.
I like it. Okay, so we've got AI generating this visual feedback, but let's get really wild here. What if the AI could not only generate those sketches, but it could also perceive and respond to visual feedback from us?
Whoa, now we're talking. A two-way street, like a truly bidirectional visual communication channel between humans and AI.
Exactly. Imagine you're, I don't know, sketching out a rough design on a digital whiteboard, and the AI, it instantly gets what you're trying to do. It fills
Mhm.
in the gaps, maybe suggests some improvements, or even generates some alternative designs based on what you drew.
That would be incredible. Talk about a true partnership. It revolutionized so many fields, design, engineering, even art. Architects could work with AI to create, these amazing buildings. Musicians could jam with AI to compose music. The possibilities are, well, they're endless, really.
It's a wild thought for sure, but got to be realistic here. We're still a ways off from AI that can really understand and respond to human sketches on that level. There are some big technical challenges to overcome.
For sure. This is novel notions after all.
Yeah.
We're allowed to dream a little. But even if these specific ideas never fully pan out, they can still spark new research, new directions, new breakthroughs we haven't even thought of yet.
Absolutely. Who knows what the future holds, right? What seems like science fiction today could be reality tomorrow.
That's the beauty of it all. Well, on that note of boundless possibilities, I think it's time to wrap up our deep dive into ReFocus. It's been a fascinating journey.
It has. As always, listeners, we encourage you to check out the show notes for a link to the paper itself, if you want to dig in a little deeper. And hey, share your own novel notions with us on social media. We love hearing what you're thinking.
Until next time, keep those minds curious and keep exploring that amazing world of AI.
And that's a wrap for Talk Tensors. See ya in the next episode.